Hello, welcome to my YouTube channel. My name is John Young. In this episode, I'd like to discuss a material that I haven't talked about before. It's very different from the subject matter I'm used to talking about, but it's still been very dear to my heart for a long time, and I wanted to share it with you. The material I'm talking about is the proposition that large megalithic monuments in the old world may have been constructed to commemorate specific astronomical events. And one of the monuments I'm talking about is Stonehenge, which I'm sure you're all very familiar with. It's well known as a large collection of very huge stones, or megaliths, that have been dug and stuck into the ground to create a large circle in southern England. But some of you may not be aware that there's evidence that the builders of Stonehenge may have been interested in astronomy and used the monument to commemorate specific astronomical events. And when I talk about astronomy and Stonehenge, I need to get some particular terms clear right off the bat. And one of these terms relates to the fact that the angle of the Earth's axis is slightly offset compared to the angle of the orbit of the Earth. Now, what do I mean by this? Well, if you look at a diagram of the orbit of the Earth as it travels around the Sun during the year, you can see the orbit is basically kind of an ellipse. It moves in a flat plane around the Sun. And the Earth is also spinning. And the axis of rotation of the Earth from the North Pole to the South Pole is not actually perpendicular to the orbit of the Earth. It's angled at an angle of about 23.5 degrees. So this has some specific consequences. It turns out that in the wintertime, North America is kind of tilted away from the direct rays of the sun so that they strike the North American continent obliquely. This means we don't get as much heat from the sun, and that causes the appearance of winter. On the other hand, during the summer, the North American continent is pointed more toward the sun. It gets more direct rays of the sun, and that heats us up. So that means the appearance of seasons is basically due to this tilt of the Earth's axis. Now, not only does this cause seasons, but this tilt of the Earth's axis also causes the positions of the sun to change depending on what season of the year you're in. For example, if you're an observer standing on the North American continent in December, and you look to find where the sun is on the horizon, you'll notice that the sun appears to rise in the southeast, move directly south of us, and then set in the southwest. The southern position of the sun reaches its maximum in December, on December 21st, which is the shortest day of the year and is called the winter solstice. Now, what about the situation in the summertime? In the summertime in June, the sun appears to arise in the northeast and set in the northwest. And the sun reaches its most northerly position on the horizon on June 21st, the longest day of the year, which is also called the summer solstice. So we can see that the positions of the sun change depending on what time of the year you're in. Now, this phenomenon relates to the construction of Stonehenge. If you look at an overall diagram of Stonehenge from above and look at all the major stones that are positioned in it, you can see that there's a horseshoe-shaped collection of stones in the center of Stonehenge. And if you look at the long axis of this horseshoe shape, you can determine that it points directly to the position of the summer sun on the horizon on the longest day of the year. Now, this phenomenon has been known for a long time and suggested that the builders of Stonehenge had some interest in the astronomical event of the sunny setting and rising sun. Now, the ability to point Stonehenge in a particular position of the sun is not a difficult one because the sun rises at the exact same spot on the horizon on the longest day of the year every year, and it repeats itself over and over and over again. So this construction of Stonehenge was not a particularly difficult one. However, in the 1960s, an American astronomer named Gerald Hawkins found out some interesting facts about Stonehenge that gives us more respect for the builders of Stonehenge. Hawkins looked at 4 stones that are located at the periphery of Stonehenge. These are called station stones, and if you connect the dots between these stones, they form a large rectangle. Now, if you look carefully at some of these station stones, you can find out some interesting facts. A pair of station stones is parallel to the long axis of Stonehenge, and sure enough points to the rising sun at the summer solstice. Not a big deal, easy to understand. But if you draw lines between another pair of station stones, they point to the rising moon on the day of the summer solstice. Now, this ability to point to the rising moon is a much more sophisticated one, because the moon does not rise and set at exactly the same spots on that particular day. The positions of the moon vary depending on what year you're looking at. The reason for this is that the orbit of the moon wobbles slightly as it travels around the Earth, and that means its position varies from one year to another. For example, in 1987, the rising moon on the day of the summer solstice is located about 140 degrees from true north. But the next year is slightly different, and if you track the course of the moon over the succeeding years, you can see that at the minimum of the cycle, it reaches a position of 120 degrees from true north. And then the moon changes its position over and over again until finally it gets back to the same spot in 2006. So these specific spots are called standstill spots or standstill points of the position of the moon. And the moon only comes back to this specific spot every 18.6 years. So in order for the builders of Stonehenge to have calculated the particular spot of the moon it would occupy on the horizon of the longest day of the year, they would have to observe the positions of the moon over many, many years, at least 36 years, to exactly pinpoint where this was. So this suggests that the builders of Stonehenge had a particularly sophisticated understanding of the positions of the sun and the moon, and were very interested in astronomy. Now, in addition to this, if you look at the positions of the rising moon and the rising sun at the summer solstice, the angle between these two heavenly bodies equals exactly 90 degrees. Now, it's possible to observe this 90-degree angle between the sun and the moon only at the specific latitude of Stonehenge. Now, Stonehenge is located in the southern regions of England, called Wiltshire, and the angle between the sun and the moon is only at a 90 degrees at that specific latitude. Now, this might be a coincidence. Maybe 90 degrees is nothing special, but it suggests that perhaps the builders of Stonehenge deliberately located at that latitude so this particular angle could be observed. Now, is there any other evidence that should suggest that this line of thinking might be correct? Well, it turns out Stonehenge is not the only large megalithic structure that can be examined in England and in Europe. And more recently, a large structure has been found in Germany. This structure is called a megalithic henge and basically represents a huge circular ditch of 250 foot diameter. This ditch is located at Goseck, Germany. It's interrupted at 2 points in its circumference, and these 2 points correspond to the location of the rising and the setting sun on the day of the solstice. So this suggests that people in Germany also had an interest in astronomy, and they constructed structures that are rather similar to Stonehenge. Now, as it turns out, Goseck is located at the precise latitude that is occupied by Stonehenge. It's located in the eastern portion of Germany, right here in this diagram. And if you look at a reconstruction of Goseck, you can see that it represents a very large circular structure, probably 6,000 years old, even older than Stonehenge. And if you're an observer sitting in the middle of this large circular structure, and you look toward the setting sun or rising sun, you can see interruptions in this circular structure that allow you to visualize the rising sun or the setting sun. So this suggests that these two large megalithic structures are located at the same astronomically significant latitude at which the sun and the moon angle equaled 90 degrees. Well, this is interesting, but it's not necessarily conclusive. Are there any other megalithic structures that are located at other astronomically significant latitudes? Well, as a matter of fact, there are. If you look at an island off the coast of Scotland called Callanish, you can find that there's a stone circle located there. Now, it's more modest than Stonehenge. It's a much smaller structure, but it is located at an astronomically significant latitude. It turns out this stone structure was located at a latitude that represents the Arctic Circle for the moon. And what does that mean? This means that on the shortest day of the year, the moon actually never sets below the horizon. So this is an astronomically unusual latitude at which the behavior of the moon is very peculiar and which must have been noticed by ancient observers. So this is another example of a megalithic structure that's located at an astronomically significant latitude. And what about other stone circles? Are there any other stone circles located at specific interesting latitudes? Well, it turns out there are. There's a very large stone circle at a location near Penrith in England. This is about the sixth largest stone circle that can be found in the British Isles, and it's very prominent. And there's a similar pair of large stone circles that are found at a location called Beagmore in Ireland. It turns out at that latitude, the angle between the rising sun and the setting sun during the summer solstice equals about 90 degrees. Once again, the 90-degree angle seems to be important here. Now, in addition, an investigator named Aubrey Burrell looked at collections of standing stones throughout the British Isles, and he found out that you can find standing stones all over the place. There's many, many, many of them. But if you look specifically for long rows of standing stones, 10 or more stones that are located in a line, they're not located randomly over the British Isles, but they're found in specific latitudes. And the latitudes are the latitudes of Stonehenge, the latitudes at Penrith, and the latitude at Beagmore. So this investigation by Mr. Burrell suggests that some megalithic monuments are located at specific astronomically significant latitudes. Now, does this apply to everything that you find in England? Absolutely not. There are more than 1,000 megalithic sites in Great Britain, and these are composed of individual standing stones that can sometimes be found near churchyards, pairs of standing stones, megalithic grave sites, all kinds of structures, and they're not located at any specific latitudes. They're found all over the place. However, the very large megalithic structures like Stonehenge and Penrith and Beagmore do seem to be located at astronomically significant locations. Now, these principles do not only apply to England, but they can also perhaps apply to megalithic structures found elsewhere. One of the most prominent collections of megalithic standing stones is found at a location called Carnac in France. And at this spot, it's possible to examine hundreds of megalithic standing stones that are positioned in long rows. Now, the actual significance of these stones, which are very ancient, is not precisely clear. However, it's interesting that they're located at an astronomically significant latitude. At the latitude of these stones at Carnac, the angle between the setting moon and the rising moon during the summer solstice equals 90 degrees. Once again, the 90-degree angle seems interesting here. And you can calculate this angle between the moon and the setting moon and the rising moon by using an astronomical program called SkyMap Pro. And I did this once and published it. And it turns out that if you look at the position of the full moon when it's rising on June 11th in 2006, which is the standstill point of the moon, and you look at the position of the setting moon on June 11th, which is in the month of the summer solstice, you can find that the angle between these two positions is exactly 90 degrees. So this suggests that some of these megalithic structures are located at astronomically significant latitudes. Beagmore and Penrith, Stonehenge and Goseck, and Carnac are all located at peculiar spots in Europe. Now this type of principle may apply to yet another structure. It turns out there's a megalithic stone structure that was discovered in the 1990s at a place in the desert of Egypt called Nabta Playa. This stone circle seems to have some astronomical orientations, much like the stone circle at Stonehenge, and it's also very, very old. It certainly predates the pharaohs and the other civilizations that came later in Egypt. Now, at the latitude of Nabta Playa, the sun at noon is directly overhead on the longest day of the year, and so it casts no shadows whatsoever, which is a kind of an eerie and peculiar phenomenon that other ancient people seem to have respected. So if you look at the locations of all these major megalithic constructions, you can see a pattern. The stone circle at Callanish is located at the Arctic Circle for the moon. Circles at Penrith and Beagmore, the angle between the setting sun and the rising sun equals 90 degrees. At Stonehenge, the angle between the rising moon and the rising sun equals 90 degrees. At Carnac, the setting moon and the rising moon equals 90 degrees. And at the location of Nabta Playa, which is about a degree south of the Tropic of Cancer, we can find that the sun is almost directly overhead at a specific day of the year. So this type of data suggests that there's a method to the location of these megalithic monuments. Now, if you're interested in this kind of information, I wrote a book about it called Sacred Sites of the Knights Templar. Half of the book is dedicated to these astronomical evaluations of megalithic sites. And the other half of the book is dedicated to an organization called the Knights Templar. The Knights Templar have no direct connection to the megalithic monuments, but it seems like many of their rites and beliefs may have centered around interest in astronomy. And in this book, I'm trying to discuss both of these topics at once. Another book I recently wrote suggests that there might be animosities between scientists that may lead them to commit murder and struggle for power and glory. And this is a fiction book that might also interest you. So if you want to pursue some of these topics, I'd invite you to subscribe to my YouTube channel. And also on this channel, I posted additional videos that might interest you. So thanks for your attention. That's all for today.